Today we are going to be disassembling and discussing the theory of operation of a Keurig Classic model K50 coffee maker. Keurig coffee makers are wonderful machines, but when they need repair they can be challenging to disassemble. Removing the screws is only half the battle, since there are snap fasteners inside that are not accessible from the outside. I'll show you how to open those up without damaging the machine so that you can get inside and repair it. On the K50 Classic, the outside shell of the machine consists of two separate pieces. The first piece is this piece here along the side, here, including this front step here that holds the external water tank when the external water tank is in place. This piece here is separate from the rest of the shroud, and the rest of the shroud is along here, of course, and toward the front, all one piece. In order to remove all this, we need to remove 6 screws total from beneath. 3 of the screws belong to this piece here, and 3 of the screws belong to the rest of the outside shroud surrounding. And those need to be removed first from the bottom of the unit. The bottom of the unit, the base of the unit, does not need to be separately removed like it was on the older units. The older units had a metal plate that needed to be removed first, and ground wires connected to a rivet that needed to be drilled out. None of that needs to be done on this Keurig Classic. Instead, the base of it is a part of the overall chassis. Next, we'll begin by removing screws on the bottom. Along the bottom, I'm going to point out the screws that need to be removed. I'm not going to go ahead and remove those on this video, but I will point them out so you can see them and remove them yourself. This piece here is a separate piece. It has 3 screws on the bottom. One you can see there already. Another one there. One on the back of it here. You can already see another one that belongs to the greater part of the cover that surrounds the rest of it. There's one there. And another one up inside there. You can see kind of hidden in a cavity. Those all need to be removed to make the next steps coming up easier to accomplish. Notice that I am not turning the unit upside down to remove these screws. There is tubing inside the unit that depends on having air and only air in that tubing. To turn the unit upside down may mean that water gets into that air tubing, and it may damage the air pressure sensor inside and also the air pump possibly. So I just remove it without inverting the unit. You may get away with inverting the unit to remove the bottom screws, but I feel like it's safer to just keep it upright. In this next step, we do need to remove the cover to the K-cup arm. In order to do that, you should be able to see 2 screws there. One there and one over there. Those screws need to be removed in order to get access to other areas. So I will go ahead and remove those screws. Now that I've removed the two screws from under the K-cup arm that hold the cover in place here and here, I'm able to remove the cover by raising up, pushing backwards, and pulling it out, just like that. Now the reason we had to remove the K-cup arm cover was because we have to access two screws that are deep down here under the cover. Off to the left side, deep down there you see. And off to the right side, also deep down in there, you see that one as well. Both of those need to be removed so that we can get the top cover off of the unit. That has to come off before we can proceed further. And so I'll take the screws out of that. I'm not going to video taking those screws out, but that's what I'm going to do next. Now we need to open up some latches that are inside here so that we can begin to remove the top cover here. There's a latch there, it needs to be opened up. That's on the right side. The latch on the left side needs to be opened up as well, eventually. But for right now, we will start by opening up the latch on the right side, because that will allow us to begin to loosen up along the rim here on the outside and work this cover up and off of the unit, starting at the right side. I'm now going to begin loosening up this latch here. In order to make progress at it though, I need to be able to pull upwards from the front of the cover, pulling upwards so that this latch will pop when I get to it. Now in order to do that, I need to open up the K-cup arm, otherwise the handle for the K-cup arm will get in the way. So I'm going to go ahead, pull up on this cover here while simultaneously popping this latch open with this hook tool I've got. And now that's open there. Now that we have the latch popped back here, we can see that this front cover here is beginning to flex a little bit. And there's a way into it now. So I'm going to try to force the screwdriver in here and pop the other latches, being careful the buttons and the circuitry, of course, and just going in a little ways. Okay, I already popped open a latch over here, mostly by the force of hand. Hopefully it's just as easy for you. There's another latch there that popped open, and over there popped open also. Latch, latch, latch there. Now as I get over here to go any further, I'm going to have to go back inside and pop that other latch. Now we're back on the inside of the unit again. I'm going to take the hook tool here and pop this latch. The hook tool is just an ice pick. I'm taking and bent the tip of it, sharpened it somewhat. Now I'm going to pop this latch open. There we go. And as you can see, it's beginning to come off. There's one more small latch up here in the very front. Shouldn't be too difficult to remove. Just kind of wiggle around a little bit and it's coming loose. And we're almost ready to remove the cover entirely now off the top. Before we can completely remove the top cover, we do have a ribbon cable here, as you can see, attached to the top cover circuit board. And also it goes to the circuit board down inside here. We will need to remove it from the circuit board down inside here. In order to remove the ribbon cable, grab from the top of the cable here, hold it while opening up the latch like I just did there. The latch is on a hinge. Now it's open. Now I should be able to move the cable slightly away and it'll come off out of the connector just like that. Now that the ribbon cable has been disconnected, we can simply remove the entire cover off the unit just like that. And here's a close-up view of the top lid cover of the Keurig. Here are the screw holes that we started out removing screws for, one there and one there, that allowed us to remove this thing. That's why we had to remove the screws. And latch there on the interior side, both of those, and latches along the outside, there, 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 and over here. Next we have to remove this side panel here where the external water tank normally hangs. In order to remove this, we'd have to slide the panel upwards, and in doing so there's this ventilation port here that kind of interferes with sliding this panel up. It's attached to a vinyl tube back behind it, and you would think that this ventilation port is going to interfere with the ability to slide this panel upwards. So in the past I have, as you can see here, I've worn this thing out quite a bit using needle nose pliers to pull this ventilation port upwards and unhook it off of this panel, since it's a separate piece, and been able to pull it upwards, unhook it, and push it toward the back out of the way as I lift this panel up. That's a lot of effort to go through. This tends to slip out of the needle nose pliers. There's a better way to take it off though, not to have to go to all that trouble, and I will show you that in the next step. I'm going to remove this side panel now by lifting it up. This ventilation port, since it's attached to flexible vinyl tubing underneath where you can't see it, the flexible vinyl tubing will allow us to stretch it as I lift up like so. And then I can pull from the bottom. The panel comes off, and you're now beginning to see the insides of the unit somewhat. We will now begin removing the outside shroud of the unit here. Before we can remove this outside shroud, there is a little latch here. We need to pop that latch, pull it back. Once we do, the cover begins to move upwards like you see there. Now that this latch here has been popped, you can see that the whole cover is beginning to get looser all the way around. But before we can take it off entirely, we have a couple more latches we need to overcome here. There's one up here, right there, that we need to pull, overcome, and then one further down there. You pull, overcome that one. Now the cover is fully loose. Now that the outside shroud is fully loose, we need to figure out how to get it off. In order to do that, we need to overcome the fact that this K-cup arm area is in the way of getting it off. So we're going to have to pull it off in kind of a cockeyed way. So we'll begin by pulling the back, flexing it, pushing it backwards a little bit. Now we'll take here, start moving this, tilting it in that cockeyed way there, and helping it from the back as well. Spreading the whole thing as we go to get it off. and now it's off. The thing will spread and flex somewhat, as you can see there. So now the cover is off. On the side of the machine, the water tank sits here. That's the inlet from the external water tank. And water gets pumped through this device here, goes in through a tube, and you can't see it in this shot, but it goes to the water pump back behind. Actually, you can see that somewhat. It goes to the water pump. This device here is now your water level sensing unit. It senses the water level in the external tank. It is no longer a magnet that sits inside the external water tank. It's no longer a magnetic sensor anymore. It's a couple of electrodes that go inside this device, and the electrodes sense the water level in the external tank. As you fill it up, the way it fills up in the tank, it also fills up in this tube at the same time to whatever water level it rests at, and this will sense it if it crosses these two electrodes. Now, if you plug in a full tank, you insert a full tank here, full tank of water, and it senses that, and this tube fills up, and you remove the external tank, this water in this tube does not go away. Unlike the old magnet-based systems, the sensing still says that there's water. You got plenty of water, so you can go ahead and brew. And but that's a misleading indication. It just means that water is still trapped in this tube, even though the tank is removed. When the add water light is flashing and water rises here to the point where it crosses these two electrodes here, it bridges between them and makes an electrical connection between them and causes the add water light to go out. Now, even when there's no water in this device at all, I have taken different resistances and bridged between these two terminals, found out that 6 megohms or less of resistance between these terminals will cause the add water light to go out. Now, 6 megohms of resistance, that's not a lot of conductivity. It doesn't take much to make that situation happen. Just from a little bit of water vapor inside the device, even when there's no water in it, just plain water vapor, signals the processor that there's sufficient water, and the add water light goes out even when there's no water in this device at all, just a little bit of water vapor bridging an electrical connection between these two. So they have this ventilation port here through a tube, and it comes out near the top of the external water reservoir. It gives opportunity to air out this device here and dry things out, get rid of that water vapor exhausting out through here, and it clears up this situation, allows this device to function as it normally should once the water vapor is gone. Now, I used to think that this tube here was to exhaust out excess water and dump it out back into the external water tank, but I've thought about it since then. There's really no opportunity for water to be driven up this path anymore anyway. The water pump in here or any other pressures inside the hot water tank should not be able to push water back through this path. This is backwards. It's got a check valve here that prevents water from flowing backwards to push water up that far and dump it back into the external water tank. I now believe that there's really no situation that could cause that, and even if there is, the main purpose of this tube here is a ventilation of the air, water vapor, to dry this device out and return it back to its normal function. Down at the bottom of the machine, is the water pump. It pumps water in from the external tank into the hot water tank and through into the dispensing needle. That's a view from the back of the machine right there. Power cord. There's another shot through the side. You can see it somewhat there. There is a shot there of the tubing going from the water inlet from the external tank through and onto the water pump. That's the water pump there. Now over here there are some interesting things. This of course is the filler port that the external water reservoir sits on. And inside this port is a plus-shaped piece here that you can see. I'm pushing it up and down with the screwdriver. And so when I'm doing this, you can see in the tube off to the side that there's water moving back and forth, reacting to opening and closing this valve. This valve, when I release it, it prevents any water from coming back up out of this filler port from any place. It keeps the water from coming back up into the tank, it seals it off. But when you put the tank in place, the tank itself pushes down on this, opens up the valve, and allows water to come in through the tank, through this filler port, and go into the different places it goes to. So if you ever wanted to blow dry air through this path here to clear this water level sensor device out here, dry it all out, you could do that by blowing compressed air through the port at the top further up, and blow air through that and on down through here. But you'd have to put your finger on this thing, push it down to allow the air to exit out. Doing that would allow you to dry this device out somewhat if you ever need to do that, because it's not indicating properly. Now further over here, this of course is going to the water pump eventually, but water goes through here. The water pump draws water in from the external water reservoir when it runs, goes through this device, goes through this. Now this is a check valve here, one-way check valve, allows for one-way water flow. It flows this direction only, going this way, will not allow it to go back the other direction. Probably the reason for that is that at the end of the brewing cycle, when the air pump is blowing that K-cup arm needle out at the K-cup arm, that pressure might actually force water, try to blow water out this path too and back out into the tank again. But this one-way check valve here prevents that from happening. Water can only flow this one direction and can't go backwards. Over here we have the air pump, which is this device. Electric motor pumps air pressure out through this line here, goes straight through here, this line, and this line, it puts the air pressure into the hot water tank. Hot water tank pressure pushes on that water in the hot water tank, and the hot water tank dispenses water out through this line here, coming out of the hot water tank, and up through the K-cup arm and so forth, out through the needle and into the pod. That air pressure coming through here, pushing into the hot water tank, is what dispenses the last little bit of remaining water coming out of the hot water tank at the end of the cycle, and gives you that blowing out sound that you hear at the end of the dispensing to completely clear out the K-Cup pod. Without that, you'd have water left in the pod, and you pull the pod out and it just makes a mess everywhere. So this is only used on this machine toward the end of the cycle, as I said, to blow out the remainder of the water in the pod. On the older machines, this was used for the entire dispensing cycle to dispense all of the water from the tank into the cup. On these newer machines, however, the water pump itself is what brews during most of the cycle, pulling water from the outside tank into the hot water tank and pushes it out the K-Cup arm. On the older machines, the water pump was only used to fill up the hot water tank before the brew begins. On these newer machines, now the water pump is used to actually perform the brew, pulling water out of the external tank into the hot water tank and simultaneously dispensing it into your coffee cup. And the air pump is now only used to blow out that last little remaining water in your K-Cup. So here, this device here, the tube leads to, believe it or not, just a hole here in the wall. It's a dead end, except that it's a hole, and it can go to the outside world. Air could actually leak out here and defeat the purpose of this whole mechanism, since there's a hole there, and there's a way for it to get out. Except that that's not what this is for. This device here, it's not a check valve, as was discussed in a lot of the older machines, putting a check valve. What this is just a pressure release valve, a high pressure release valve. And under normal circumstances, this should never even operate. It will keep this path closed so that no air pressure can go through this tube. I think this is just for unusual situations, like maybe your needle on your dispenser, on your pod dispenser, the needle might be clogged. If it was 100% clogged, where would all this air pressure go? Well, this relief valve, pressure release valve, I believe is the thing that opens up and relieves pressure in case you get into a situation like that. I'm going to go ahead and try to release this here so we can look at it. Okay, I just released the latch there. Latch holds it in place. Now I'll open it up. If you're like me, you get a better sense of it if you see a picture of what's going on. So here we go. Let's try to do this latch and the other latch on the other side. Okay, that latch, there we go. And, well, actually this spring fits in there like that. And it goes in there into a port like that. Little plug here. Goes into this receptacle, hole in the receptacle. And, it's got a spring. And yes, I've tried putting my mouth on the tubing and blowing to see if I can blow this thing open to simulate the pressure release. And I can't. It's too strong, as it should be, because it's not meant to be used very often, just in a minor emergency of having too much pressure. I'm going to push this back together again, like that. Okay, so now here we got, there's this tube here. That's the only thing I haven't spoken to yet. This tube here goes off to the circuit board that you can't see yet. It's over here. Actually, you can see it. It's in your picture now. Yeah, it goes over here and goes to the circuit board there. This is a air sensor chip, same kind as has been on previous machines. I don't know if it's the exact same part number, but it does the same thing. It's been there since the original ones. And there you can see that chip with the pressure tube going to it. The circuitry needs to know what kind of pressure is developing. It reads that and makes decisions based on that pressure it's reading as to what's going on, whether there's anything wrong going on, or whether you're at the end of the brew cycle and everything seems to be complete based on the pressure that it's reading. All this talk about a hot water tank, figured I better show you a shot of that right there inside. Hot water tank, not to be confused with the external water reservoir tank that you fill up from your faucet. This is what actually heats up the water inside the machine. If I shake it here a little bit, you might see the water level going back and forth. The top of it is plastic, the bottom is metal. Up here at the top of the hot water tank, there's an electrical probe here that goes all the way into the tank. It goes down far enough that when the water contacts it, it signals the processor that there's enough water in the hot water tank that it can begin the heating process of the water in the hot water tank and get ready for the next brew. And if there's not enough water in the hot water tank, it will pump some more in using the water pump until it gets high enough that it touches that electrode, and then, like I said, starts the heating process of the water in the hot water tank. Now, on the older Keurigs, there were several of these probes. Some were longer than others, sticking further into the hot water tank, corresponding to selecting which cup brew size you wanted, more or less brew in your cup. So when it would hit one probe over the other, it would stop filling and dispense it out according to what cup size you selected. These new Keurigs don't work that way anymore. There's just this one probe that tells the processor when the tank is full enough to heat. And the cup sizes, I believe, are determined by just how long the water pump pumps water when you select your cup size. And there's another shot of the bottom of the hot water tank where it's metal, and you can see the wire electrodes connected up to it to give it power to heat it up. The hot water tank there, you can see the water pump just below it with the blue label on it. This, of course, is the hot water tank here near the top. But down below, there is tied to that metal portion of the hot water tank this thermal fuse here. If the hot water tank ever gets excessively hot, that thermal fuse will blow and open up. That will totally disable the machine. You will get nothing. It won't even turn on. It'll be totally dark. Now, on the older machines, they had this thermal fuse too, but they also had a thermal switch that would shut off at a lower temperature and reset itself again if you're lucky. But on these newer machines, they have eliminated the thermal switch. I guess they thought it was redundant, perhaps. Now they just have this thermal fuse to prevent some kind of runaway overheat condition. It will disable the unit unless you replace that fuse if it ever blows. Here is a close-up of it. And there's another view looking in from the side at the thermal fuse that's fastened to the side of the hot water tank. Deep down inside here, fastened to the side of the hot water tank where it's metal is a thermistor, a thermal resistor that responds to the temperature of the hot water in the hot water tank when it's being heated. The thermistor measures anywhere from 50 kiloohms at room temperature all the way down to 4.8 kiloohms when the water is fully heated properly like it should be to brew a cup of coffee. You can see the white wires coming up from the thermistor looping around and leading up to the processor board here where it's plugged in this plug. Now this thermistor is not an emergency cutoff. Once again, this one is to tell the processor that the proper temperature of the hot water has been achieved so that the heating process can be shut down because the water is as hot as it needs to be. The thermistor is buried deep down in here. That's about the best shot I can get of it since it's pretty hard to get to with the camcorder. It's located at the end of that run of white wire you see there. This switch here tells the processor that the lid has been opened up, the K-Cub arm has been opened up, closed, and open. Underneath the dispenser arm and back further behind is a hole of sorts, a portal, and water would normally just dump straight out of that during the dispensing operation if it were not sealed up. Now what seals it up, you can see a pad slightly to the right there. That pad swings up when you close the dispenser arm and it seals up that hole. You can see, I'll try to demonstrate a little bit, it's hard to keep the angle, but see that pad there? It's going to swing up somewhat. That pad is swinging up. It will swing up all the way with that mechanism there, although you can't see it. It's out of sight now. That mechanism there swings the pad all the way up when it's fully engaged and pulls itself back. And this, I believe, replaces one of the valves that used to be in the old Keurigs years ago. It's needed for ventilation or pressure release or some such thing. And this is the replacement for it. It's just a mechanical mechanism that opens and closes to release pressure like that. So that's one thing. If you see that, water's not going to dump out of it normally because that white pad should cover it up just fine. And that's where it is back in the mechanism. In closing, I'd like to thank all the people on the old SingleServeCoffeeForums.com for their help. That forum no longer exists, but while it did back in 2013 or so, those people there were a great help in getting me started learning how to fix these machines. To MJF and everybody else that was there, thanks for your help.